Hello everyone, this is Preen. With the advent of globalization, electronics need to meet the power requirement of different countries. Especially during the R&D and production stages, voltage and frequency variation tests are essential. There are two ways to conduct the voltage and frequency variation test. One is using a variable transformer along with a motor generator, and another one is using frequency converter or programmable AC sources, which provides remote control capability. Let's take a look at some differences between variable transformer and programmable power sources. Both variable transformer and programmable power source can adjust voltage. But the programmable power source provides extra functions including programming memory sets, remote controls, accurate measurements, and power line disturbance simulation. In short, although both products offer high reliability, the variable transformer has basic voltage variation functionality while the programmable AC source offers more sophisticated applications. Now we will conduct 3 different applications through a variable transformer and programmable AC sources. Let's start with the voltage variation test. We have set the output voltage to 220 volts and would like to have the voltage to be 10% more, which is 242 volts. Now, the meter reads is 246 volts. When we switch down the voltage 10% to 198 volts, the meter shows 200 volts. Next we will have our programmable AC power source, the AFV-P series for the same application. We set up the voltage testing group via the step feature, which are 220 volt, 242 volt, and 198 volt, same voltage we used for variable transformer. The accuracy of AFVPS output voltage is up to 0.1% as the meter shows. According to our demonstration, the programmable power source has easier operation and more accurate measurement. Plus frequency adjustment is also valuable. On the other hand, the variable transformer has less convenient operations. For second application we will compare remote control and measurement. Users can read the parameters through the pointer of a variable transformer, while programmable power sources show the numbers of parameters directly. Moreover, with multiple communication interfaces and pre-program, users are able to operate sophisticated sequences via programmable AC source remotely, which cannot be done via a variable transformer. Lastly, let's compare programmable features by simulating the short interruption test. The voltage of the variable transformer is 220 volts. As you can see, it is hard to conduct a 2-second short interruption because it is much slower to adjust the voltage by turning the knob. The results could be inaccurate due to slow response time. The advanced features and intuitive interface of programmable power sources provide easy operation for short interruption test. As the oscilloscope reads, the short interruption waveforms are more precise. Some users purchase motor generators and variable transformers to adjust voltage or frequency. Programmable power sources can meet the same features, moreover, it offers more advanced functions. For users who need frequency variation testing for different fields such as home appliances, electrical electronics, motors, and electric vehicles, frequency converters or programmable AC sources are great solutions. Thanks for watching. Don't forget to like, share and subscribe. You can also follow us on LinkedIn for the latest news.